Hello, everybody. Good evening. Welcome to week 3 of Advanced Programming with Java here at Portland State. Quick overview of what we'll be doing tonight. First, we'll have Prime Minister's questions. I'm really curious to hear how your Project 1 went, and if there are any questions related to that, I'm happy to talk about them. Also, the cones in Project 2, all the other stuff that you got going on right now. Then we'll begin our exploration of pair programming. That's probably the big thing going on tonight. And so we'll talk about coding katas. We'll talk about pair programming. We'll also talk about Project 3, the next evolution of your project. Let's see here. So then this is going to be a little different from the first couple of lectures. There's going to be a lot less of me talking. Less for you to listen to, but you'll be working in pairs instead. I'm glad there's so many of you, and I'm looking forward to leveraging this classroom in particular for that. It's a great environment for it. So to start off, tell me about Project 1. So what were your experiences? What did you learn? What did you think of things like unit testing and developing in Java using IntelliJ, all that good stuff? Yeah.
I like unit testing after I have something started. But starting from nothing and writing failing tests, I hated that.
Okay,
So I started with a core of stuff, then wrote the unit test for that, and then I started iterating through writing test after test.
So like, how much did you write without unit tests before you felt comfortable and felt it was worthwhile to write unit tests? Like, how much did you have sketched out? Did you write all of it and go back, or is it like, no, I have a class and then I can start?
About halfway.
Okay.
I wrote the airline and the flight classes in a very rudimentary name, and then I wrote the unit test for the airline and flight, and then I started writing the checks.
Cool. Nice. What were other people's experiences with unit testing and the code coverage? Right, that's like brand new. Never done that. I saw a couple people posted. It's like, I didn't quite get there. Yeah.
I found that the integration testing was a big piece of this one because it used so much command line intake. So I'm glad that you updated that.
Yeah. The integration tests. So that accounted for a lot of your code coverage coming from that, because I bet there's a lot of logic there in your main, right? That's not surprising for Project 1. It's mainly about command line parsing. So okay, that's a lot of your logic. Good. Other people's experiences. Yeah. Test-driven development. Yeah. Works for you. Excellent. Good. Glad you got to experience it and glad you enjoyed it. Okay. Any questions about Project 1? Anything that you're still wondering about? Yeah.
Sorry, just to clarify. So the integration tests do count now for the...
The integration tests do count towards the code coverage. And because that was just a bug. I hadn't done that yet. And so thanks for being the guinea pigs on all of that. And I updated the archetype. But I'm guessing that most of you had already created your project from the archetype, and so then there's there in Slack, there's a link off to a change set on my GitHub that said, oh, this is what you need to add to your POM in order to get all that to work. Okay. Any questions on the cones? Everybody doing the cones? I hope so, because there's a lot of them. It catches up on you. Yeah. Anything that was surprising that you encountered while doing the cones? It's all a blur. That's fine.
The Java constructor is kind of interesting. How it seems to take a default parameter and set a member variable that explicitly actually being set.
Oh, the fact that there's you mean the default call to super?
Yeah.
Yeah. Yes. Right. And so that's, and I guess that makes it easy for. Because so yes, in the Java language, when you have a class, you have a constructor, it has to invoke some one of the inherited constructors. Now, why is that? Has to initialize inherited state, right? And so so when you're creating an instance of your class, you need to make sure that your superclass is initialized. And so therefore there must be a call to a superclass constructor. Well, it'd be kind of annoying. So Java-lang object has a zero argument constructor, and it would be kind of annoying to just have a class that extends object, but then have to explicitly say super paren. And so then the authors of the language decided that it would be okay to put an implicit call to a zero argument inherited a zero argument constructor from your superclass just automatically. It would still compile, so that's implicit. It's one of the sort of, there's a handful of sort of implicit things that you need to know about, but compared to other languages, it's not so bad. Cool. Project 2, due next week. People started on it, I hope. What are some of the things from Project 1 that you want to make sure to do in Project 2? Get a good grade, obviously. Write lots of unit tests. I don't know. No? Nothing? Yeah? Okay. Yeah?
We'll be implementing the date properly now, right?
That'll be Project 3. You can do it in Project 2, though. You can use date at any time, especially if you're watching the lectures and you're starting to be curious about the class. Yep, you can do it at any time. It's not really required until Project 3, though. Yeah. Yeah.
What am I using date about calendar?
Oh, date, not calendar? Well, a calendar has a date. So, but one of the things that I want you to learn, and something I emphasize in the lecture, is that there's an important separation of responsibilities between the date, which just represents a point in time, and then the calendar, which is all about getting information about that point in time in the context of a calendar, right? Because there are multiple calendaring systems, and so then you can then format and get information about a date based on the calendar. Does that make sense?
Yeah.
Okay. Good. Anything from Project 1 that you don't want to do again in Project 2? Anything you want to confess to? I'll hear your confessional. That's weird. No, nothing. Okay. Awesome. Okay. Let's see here. Everybody did the quiz, I hope. There was a quiz too. Okay. I don't think I've given you any other work, so stay tuned for Project 3 later tonight. Nice. Okay. Let's start talking about pair and mob programming. Okay, so I wrote an essay about pair and mob programming. So, for a long time, there was this stereotype that persisted within software engineering of the lone programmer out there, in the cave, programming all by his or herself, writing the code. Sorry, guys, you kind of distracted me here. So if you notice, if you want to talk at school, you go to the back when you go outside. But yeah, thanks. So. There was, for a long time, we thought the way we did software engineering was alone. And then we, relied on these superhero programmers that knew everything and that would, go toil away in the dark for hours and come out and have this thing that would be beautiful. And a lot of people got paid a lot of money to do that, and a lot of really crappy software was developed. And one of the things that the craft learned, and this is actually something that they knew from back in the old days, is that when people collaborate and when people work together, you get better results. Ideas are vetted faster. There's faster feedback on things, and what you get is decisions that are made in a more global context as opposed to just locally optimizing for what's in front of you or the thing that you're trying to figure out right at that second. So today, software engineering and software development is seen as a team activity. This is things that multiple people can contribute to, whether they're sort of playing the same role or whether they're multiple people, like someone who's looking mainly at quality or mainly at usability, and then other people that are looking at the technical implementation or the performance of the system. And there are two real personifications of this. Personification is not the right word. There are two approaches to software development that really resonate in this team-based environment. Pair programming and mob programming. Tonight we'll be learning about pair programming, but the whole idea is that you've got multiple people that are simultaneously looking at the code while it's being written. Now, at any one time, only one person's hands are on the keyboard. But the idea here is that we have multiple people collaborating on the code, in order to enable really rapid feedback loops. So you find bugs literally seconds after they're written, instead of having to wait for, at best, your unit test running or compiler telling you, and at worst, you checked in some code and then you find out days or weeks later because someone else tested your code. This helps you make decisions faster, and it helps spread information throughout the team, throughout the group of people that are working on the code. So it really is more of a global optimization than it is a local optimization. And so one of the things I want you to experience in this course is what this is like. This is still, as far as the profession is concerned, a relatively new and, quite frankly, controversial aspect or technique for software development. And what you'll be doing is experiencing both pair and mob programming here in class, implementing what are called code katas. These are simple little programming projects, little assignments, that are meant to let you explore a new language, a new library, something new. They're teaching exercises, kind of like the cones, in that they're meant to be straightforward and contained. Now, this is pair work, this is collaboration work, and so then unlike your individual assignments, this code can be out there in the open. And so one of the things I'd like you to do is collaborate with your partners in a public GitHub repository. And I know a number of you have been using GitHub, so I think between any given pair or in any mob, there'll be enough people that are familiar with GitHub so that you can collaborate effectively in this. Probably the easiest way to get started, and we'll get started tonight, is by doing what you did for your individual projects, taking that getting started repository, going through that workflow again where you make another repository based on that, and whatnot. But this time make it a public repository, add your partners as collaborators so they can all contribute to the source code. You'll also be able to leverage the things that are in the Getting Started repository. I have a script called Create Simple Project, which is basically what the Create project 0 and 1. Actually, the Create Project 0, I think, uses. It'll create a simple Maven project for your Kata's code, and we'll walk through this together as a group. Now, this is not only a fun in-class activity, this is part of your grade. That's the way I can get you all to stay here. And so then what each student is required to do is participate in one pair programming exercise. So there's one tonight, there'll be one next week, then there's the week off, and there's the one after that. So there are 3 opportunities for pair programming. You're required to participate in one, although you are more than welcome to participate in 2 or all 3. Similarly, there's one required mob programming exercise activity to do in the class. So what we'll do is we'll get our environment set up, then we'll do a little bit of programming, then we'll come back and have an in-class discussion about our experiences, what we learned, and give people an opportunity to show off some of their solutions. And we'll do a couple of rounds of that here in class. The thing that counts for your grade is a reflection. So this is an opportunity, well, it's not an opportunity, you are required to provide me with some observations that you have about pairing and mobbing. There's basically a quiz on D2L, one for pairing, I think it opens tonight, and then one for mobbing. And there's a handful of questions that I want you to answer about your experiences. So I want to know who you worked with, either the pair or the people in your mob. So it requires that you sort of know who everybody is. Also, I want you to provide a link to the code so I can go check it out and sort of see what you did. I'm not going to execute it. It doesn't have to necessarily work or anything. It's more about, I'm just curious about how your pair or mob was able to do. Sort of reviewed for completeness. So if there's nothing there, that'll be a lower grade than if I can tell that there's evidence of work. And there's also some writing. I want you to tell me about your experiences, like the things that you observed, the things you felt, how you reacted to it, and then what you learned. And then more generally, I'm curious on which situations you think that pairing or mobbing would be effective and where you think it would be ineffective. So it's a little different. This isn't just programming. This is programming and thinking and writing. But it's all part of the package here at Portland State University. So, and this is all a great experiment. Never done this before. So we've done pair programming and stuff, but we've never really reflected on it. And I'm curious to see what your observations are. So any questions about sort of your expectations with regards to doing these katas for pair programming and mob programming? Yeah,
Where are we going to submit the reflections?
it's a D2L quiz.
Oh.
Yep. D2L quiz, huh? That's cool. Yep. Okay. Let's learn about pair programming. Oh, you know what? I need to plug in the audio. Which audio? Zoom. I'm recording, right? Maybe. Should be. Yes, good. Let's make it big.
Hello, and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver who actively types in the computer or records a design, and a navigator who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving stuff. So we create a new patient and that's record. Oh, probably in saved data file. So it's going through, looks like a list of records.
So probably since we just added the height and weight, I don't know if that's actually good.
Yeah, probably not. So
Why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
what was yours?
You would program by yourself, so you usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it can be really frustrating. You'd sit there banging your head against the desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen, too. Both the driver and the navigator should be fully engaged in the project, so much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation, too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, to teach is to learn. And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they're from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun. Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hopper, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
Yeah, if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also, with pair programming, you can typically have higher grades on assignments, there's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Wow, like a whole minute of credits. Kind of cheesy, but what were some of your observations about pair programming? Say what? Hygiene? Is that what that was? Who said that? Yeah, right, yeah. So, sorry, it's too late to go take a shower. I don't know. But yeah, I mean, yeah, you're working with people, and so then, yeah, if you had like the garlic pizza for dinner, pop them in or something. On the coding or technical side, what are some of the things that you noticed, or some of the things that you might want to experiment with tonight to make that successful? Oh, okay. Yeah, like write a function or write a test, and then that'd be a good boundary. As one person, yeah, helps write the test, get it passing, and then pass the keyboard off to somebody else. Okay. What else? Any other ideas how you're going to approach this? Yeah.
Don't be a backseat driver. Every time they miss a semicolon, give them a minute.
Right. Yeah. Don't be that naggy backseat driver that's always like, wait, you missed that, or you missed that. It's like IntelliJ is underlying in red. You know for a reason. Yeah. Good. Okay. Yeah.
So if two persons' approach is so different, and there is no right or wrong, what should we do?
Well, that's right. I mean, so what happens when you have a disagreement, or you're like, oh, I think it should be that way. I think it should be this other way. I don't know. What do you think?
Collaboration is the art of compromise.
Yeah. Ultimate fighting, cage match? I don't know. No. Please don't do that. Don't have to call the police. Never had to do that. No, yeah. But yes, I mean, and actually, it's really healthy to have sort of the pros and cons. There isn't necessarily a right answer. There's, okay, one approach might have higher positives, the other one might have lower negatives, and figure out which one it is. But since you're working on together, really the most important thing is to get it working and get it working well. And then you need to decide how much time you're going to invest in debating style, refactoring. And I think it's fair to expect that the first time you do it, the first time I pair with somebody, it's kind of awkward because it's like, hey, I've never worked with this person before, and I don't know how to approach it. But I found that over time, especially when you pair a lot with one other person, but even as you sort of get more people involved, you learn a lot, and it helps you improve how you code because you get to see how other people approach their code. Good. Yeah. Okay, let's find pairs. So let's take like 5 minutes. Find someone to pair with. Introduce yourself if you don't know each other already, and then we'll talk about the kata that we're going to write. And if anybody would like to pair with me, I'm open for pairing. Okay, I hear people talking. Everybody's getting to know each other. Okay. Okay. So let's introduce the programming kata that we're going to be working on tonight. So these katas are little programs, little programming projects, and they're often used with a group of people want to learn new language, and so they take a simple problem here and implement it to learn more about the language. So our first one is it's the first one we're going to do tonight, or sorry, tonight's kata is called leap years, and this is appropriate because 2020 is a leap year, and so then the whole idea here is that we basically want to implement some logic that determines whether or not a year is a leap year. And for those of you who are not familiar, here are the criteria by which you know something is a leap year. So if you have a leap year that is divisible by 400, those are leap years, like the year 2000 was a leap year. A year that's divisible by 100 but not 400 are not leap years. So 1700 and 1900 were not. Any year that is divisible by 4 but not by 100 is a leap year. And all years that are not divisible by 4 are not leap years. So 2019 was not a leap year. So it should be pretty straightforward, right? So here's what I want you to do. We're going to brainstorm some test cases for this kata. And then we're going to, and so what I did is I created a Google Doc here. Let's see here. Anybody edit this? Do I want people editing it? Here's what I want you to talk. Actually, no, go ahead. I'll make it so that anybody with a link can edit this. Anyone with a link and can edit. What the heck? Don't do anything. Don't have to face the property. I will post this in Slack. Here's the document in which you can capture your test cases. And so I'll leave these up here. Let's take, 5-7 minutes to brainstorm some test cases. And I recommend that when you think about your test scenario, you say, okay, given some situation, when something occurs, then I expect some output. And so, I don't know, given that I have a year, 2020, when I check to see if it's a leap year, then I expect it to be a leap year. Maybe it's a little verbose in this case, but this is how I encourage people to think about testing their code. You've got some situation, a given situation, when some action occurs, when some operation occurs, then I expect some output to occur, some outcome to occur. Make sense? So work in your pairs. If you want to talk with other pairs about this, that's totally cool. So the whole idea is we're just trying to sketch out what is our code going to do. So I'll give you a couple minutes to do that. Meanwhile, I will go upstairs and get the keyboards if we want to share keyboards.
So basically, if it's
yeah, okay, I see that. And then, but also the number 3 is number 3 is kind of more like I feel like number 1 is extension.
Yeah.
I put it in Slack. There's Kata's channel, not
So if it's invisible by 100, it doesn't matter if it's invisible by 4 or not, it's not.
Okay. So it looks like people brainstormed some good ideas for the leap year kata. These are some, let's see here, some good test scenarios. We've identified numbers and leap years. Okay, excellent. Okay, so like I said, I recommend that you use GitHub to, actually I guess it's kind of a requirement, that you use a public GitHub repository for the katas. So let's take a couple of minutes as a group to create that repository. It's a lot we did on the first day of class, but it's been a couple of weeks. And so let's review that whole process again. So let's see here. Is that right here? Well, whatever. Okay. So back in week 1, we talked about the Getting Started repository. Getting Started GitHub repository. So create a new public repository following the directions here. So I recommend that we create one, that each pair create a public repository in one of your GitHub accounts. So let's see here. I guess I'll do this, and I'll make a public repository. So let's see here. So the first thing I need to do, let's go over to a shell. Let's see here. Push D back here. All my Git stuff. I want to make a bare clone of this repository. So that'll start it there. Then I want to... Oh, I need to make a new... this will be a public repository this time, so I'll do that in GitHub. So I say new repository. I'm going to call mine something very Java Winter 2020 katas. You can call yours whatever you want after your favorite Korean anime character. I don't care. Let's see here. I want it to be public. I do not want to initialize it with a README. It's going to have one. I don't need a description right now. Oh, I could have called it Congenial Spork. Thank you, GitHub. You're whimsical. Hey. I wonder if they translate that for different languages too. Anyway, right? Anyway. Okay, so I will create this repository here as me. See, it's a public repository, so it doesn't have anything yet, and that's fine, because now I want to go back to my Getting Started repository, follow the directions there. I made my bare clone already. I want to cd into my clone and started git. Now I want to push it up. Right. Now I want to push it up to my public repository. Sorry. Now, are people following along and getting it all? I hear a lot of people talking. I don't know if you're working on it. So let me know if I'm going too fast, I guess is what I'm saying. I don't really want to repeat myself, but I will if I have to. Port 700 to katas. Yep, I think that looks right. So now push my bare clone up there. Oh, I don't want to, sorry. You all can use HTTPS because you know your passwords. I want mine to be this thing. I want the SSH one. Oops. I copied that to the clipboard. I thought that would work. I have to say paste. Paste. Okay. So then populates my new repository with my bare clone. I reload it. All the stuff is there. That's good to know. Okay. Okay. Have people gotten this far yet? Do they have their new public repository with my stuff in it? Yeah, okay. Cool. And and now I need to add collaborators. So the way I do that is I go to settings, and I say collaborators. I need to enter my password. Well, okay, so my password manager knows my password. And now I can add people. Somebody shout their GitHub ID. Riley Everett. Is that you? Great. So ask your partner what their okay. So he knows what their GitHub ID is, and add them as a collaborator. And what collaborators can do is they can push to your repository. So we're going to talk about the best way to actually share the keyboard in this case. And that will, by adding the collaborator, it'll send them a link to collaborate. Yeah. And once you do that, you've got yourself a repository that now you can clone. There's a Java Winter 2020 katas, and you've got all your stuff. So I recommend that you do some Maven clean verify. Sorry, you do a Maven W clean verify just to make sure that everything works after your initial checkout. And actually, let me talk about when it comes to sharing the keyboard. Now, remember how we talked about hygiene? I know that I don't let just anybody touch the keyboard on my machine because I touch the keyboard on my machine and it's cold season and there's like this whole coronavirus going around. Apparently, when you drink Corona, you get really sick or something. I haven't been paying attention, but I have, courtesy of your computer science department, so your tuition at work. How many is this? 10 bucks, 20. Well, maybe it's 20. I don't know how many there are in here. USB keyboards, only the finest USB keyboards that Warren Harrison could buy on eBay 5 years ago. If you'd like to use a USB keyboard, put it on one person's computer and share that way. Yes, you're still touching a keyboard, but it's not your keyboard. Feel free to use it. These also have mice in them. I bet they have like mouse on actual mice and rats. I don't know where they keep it. Alternatively, because you're sharing through GitHub, when you want to switch partners, you can have one partner commit their code, push it up to GitHub, have the other partner pull it from GitHub to get those latest changes. So you've got a couple options in terms of whether you want the authentic pair programming experience where you're literally passing the keyboard back and forth, or if you want to use GitHub for that. Sound good? Let's see here. Are you guys pairing together? I just kind of want to. Well, I want a table space to put some of these on. So.
You have to provide two CPUs.
Yeah, let me get to that. Actually, I'll get to that next. Okay. So next, I'm going to open up my project in IntelliJ. Let's see here. PSU get. No, I don't want that. Portland State winner. There we go. Katas. Oh no, that's not what I want. Okay, good. And pom.xml. I'm going to open up the top level POM. Open it as a project in a new window. It's thinking about it. It's going to detect all the stuff. I've got all my katas now, and so I don't have anything yet. And so the question was, oh, hey, there's this create simple project script. How do you use it? Oh, I've only got, you know what? I don't have a command version. I'll take care of that. Anyway. Actually, I do chmod, don't I? Create simple project. It takes two arguments. One is a project name, and the other is the student ID. You can make up some name for your pair or whatever. And so the project ID, we'll just call it leap year. I don't know. And then, or leap year kata. And then the student ID, mine would be Whitlock, and you can call yourselves, the Wonder Twins, or Batman and Robin, or yeah, okay, whatever, or what was that, Copacetic Umbrella, or whatever the name of your GitHub repository is. And now if I refresh in GitHub, I've now got a Leap Year Kata project that's based, I believe, on student, right? Oops, it doesn't. Oh, I need to import the changes so that it knows that it's a project. And now I've got the student project. Okay, so then you can use this. I'll probably do things like, well, actually, let me just make sure that everything works. Okay, everything seemed to work. So now I'm just going to go ahead and add leap year kata, git status, lots of files, all sorts of good stuff. Git add pom.xml, git commit, added a leap year kata project, push it up to GitHub. Okay. How are people doing? Have you gotten the student project? Have you gotten the Leap Year Kata project yet? Let me post some of this stuff. I've been issuing lots of commands. I'll put a couple of things in Slack so people can see it. Let's see here. So after you've created your repository, do a git clone of it. And make sure that maybe verify works from the command line. Then open up the pom.xml in IntelliJ to see your project. Then use the create simple project.sh script to create a new project. Synchronize IntelliJ project. Do a maven clean verify. W clean verify. Again to make sure the code builds. Synchronize your IntelliJ project to get the new Leap Year Kata project. Commit your code to Git and push it up to GitHub.
No, it's the class history. The worst one is tomorrow after this one, at 6. Like with the amount of people and so
Okay, where are people at right now? Yeah, okay. Oops. Sorry, Michelle. Okay. Show of hands, how many people have a project now in GitHub? Who's got a project? A couple people got a project. A couple people got a project. A couple people don't. Of those who don't, okay, one more thing I recommend everybody do is, now that you've got like your student project created, let's get rid of a lot of the student stuff. So you can say refactor rename. Instead of student, I don't know, call it leap year, whatever you want to call it.
Oh, I see.
And it'll say, hey, do you want to rename things like the tests? So I'm like, yes, I do. And then let's see here. Let's just make sure that everything still works correctly by doing a clean verify. Cool, I'm going to commit those changes. Rename the student to leap year. Commit push. Push. And now I'm just going to get rid of all of this like stuff related to the student class, which, you know, we won't need here. As a matter of fact, let's... do I need a main? You might want to keep the main. I don't know. Let's go ahead and keep it. And then I wouldn't expect the leap year test to work. It's probably broken, so do that. And I think everything will still work. Might complain because there's no test in that class. We'll see. Yep, doesn't like it. No test were executed. Okay. So, nice. Okay. So then, this is going to be got rid of rest student code. And generate kata. Okay. And use the factor name. Name of the student, class to something else.
The only one, the other one was bringing file. How can I go stupid file?
Okay, and so now you're ready to pair program? Okay. You get I'm going to pause the recording. Let's go for a small time box. Let's go for 15 minutes. We haven't had a break yet, so let's start. Go for 15 minutes. Then we'll take a break. Then we'll come back, talk about where we're at, and do a couple more rounds of maybe 20, 25 minutes doing all this.